Hello, everybody, and welcome to SurrealDB stream number 8. Today, we are going to be talking with Toby and Emmanuel about full text search indexing. So really excited to share those updates with you all, just as we're all piling on in. As ever, please share where you're watching in from and how the week is going. We're going out live to LinkedIn, Discord, YouTube, and of course, our newly returned Twitter. Some of you may have seen that we got struck off there for a while out of kind of just a glitch in the system. So we're really happy to be back now and able to communicate with you all on there. That was a big relief. So our COO, Jamie, did an amazing job getting us back on there. We have a few really exciting updates coming for you. Predominantly, you'll have seen that SurrealDB World Conference is coming on the 13th of September, and we're all really busy preparing for that in London. The team is going to be coming over to join us, so make sure that you sign up for those tickets. We'll be sharing the link in a little bit, whether you want to attend in person, and you can, one of those tickets, it's free to attend, or as well, join us online. We'll have it all fully streamed out for you and a really nice interactive experience. Emmanuel actually shared this talk at our SurrealDB Social in London last week, and it was a huge hit. He's now been asked by Women Who Code to go and do the presentation for them as well. So really excited to, of course, share it with our Surreal community today. So I will be passing over to you both. Welcome, Toby and Emmanuel.
Lizzie, thank you. And Emmanuel, welcome. Great to have you here. Obviously, I was at your talk last week, which was amazing. Really excited to share some of these new approaches that you've taken for full text search inside SurrealDB and what that means going forward. So yeah, really excited to see what that is and to show our community, our developers, what they can do with this. Obviously, with some of the caveats at the moment being in beta, but really exciting nonetheless. So yeah, Lizzie, thanks so much for the intro. Emmanuel, welcome. And
Thank you.
I guess my first question: where do we start? Where's the best place to start for introducing full text search and indexing?
That's a good question. So let's start with the presentation, right? So this presentation will so the idea there, if we go to the presentation, is to give you a sense of the beginning of the story of full text search in SurrealDB, and give you also a forecast about what is going to happen really soon, because now it's a feature that is embedded in the product. So what we are going to see today is something that is going to be shipped in beta 10, that is going to be released pretty soon, to be confirmed. And the idea is to show you now where we stand and where we are going.
Awesome, take it away.
Yeah, okay. So let's go. So search, the search topic. I wanted to start. I mean, I think everybody knows about search, right? If I ask you guys if you are using a search engine or whatever, I mean, everybody is doing it. Sometimes I expect to have someone that will tell me it's not the case, but yeah, most of the time we know about them. I wanted to show you this widget from Google that appeared a few years ago. I think it appeared in 2014, when if you would write the name of someone and you would put full name at the end, then you would have the usual search results, but also you will have this widget that aim to find the real name of the person. You know, those widgets you also have when you want to do a conversion between kilogram and pounds. So if you put that on the search, it's going to show a widget with form that you can use to make this conversion. So the same thing was for this full name widget. And as you can see, I mean, this first version was not absolutely 100% accurate. If you look for the rock full name now, you will have this widget with the right Douglas Johnson. But at this moment, it was finding Theodore Rockefeller, right? And which is, of course, a mistake. The funny thing is that we understand how this came, right? It was not wrong from a computer software point of view, because if you look at the here, this the is exactly the prefix of Theodore here. and the rock is as well the prefix of Rockefeller. So from scoring full text search engine algorithm logic, it makes sense that it was the right guy. This is where another kind of search that we'll talk at the end of the presentation will be handy. But let's go now with the kind of search. Full text search. Full text search is about non-structured or unstructured information. You all know SerialDB. SerialDB today is a structured database, a database that takes field columns. You put a structured document, a JSON document, and for each property of your JSON document, you have a field, and you can make everything you want with this field. So if we come back to Google search and Wikipedia, I mean, this structured information are this idea of having a field and a value, right? Typically a date, a number or something. But when we want to do full text search, we want to search in the content of something that is a flow of text, right? And this is what we call unstructured data. For us as human, it's not that much unstructured because we see paragraphs, we see sentences, we see words. But again, for software, it's just a sequence of characters. And all the deal, I mean, what the full text search has to deal with is to be able to take this sequence of characters and make it something that we can request for using search functions. So unstructured, structure. So it's one of those concepts that SerialDB is going to deal with now. Oh yeah, we have also very structured, and by the way, this acronym very structured is the same than vector search. That's something that we will talk about later. Douglas Johnson on the right. Okay. Is it okay for everything, Toby? It's okay.
Yeah, no, brilliant. I was just going to make it clear. This is already in the nightly builds. What you see here is already supported in SerialDB. We're working on performance improvements and extra functionality. But what you see here, what Emmanuel is going to demo, is already in the nightly builds and will be coming to beta 10 really, really soon.
Exactly, and so this is one of the first new statement that exists now in SerialDB. We need an analyzer. So we create this concept of analyzer. If you come from the search, if you come from other platforms that are doing search, you already probably know this concept. So this analyzer, so define is probably a statement that you already know. Right? It's a statement that we use in SerialDB to define a table, a namespace, and different entities that exist in the Serial database. So here we define an analyzer. We give it a name. Here it's simple, and then we will give two kinds of properties, which are the tokenizers. Here we have camel and class, and we have the filters. Here we have Snowball English. So for the one that comes from search platform, I think it's already something pretty familiar. Let's dig in. For the one that does not come from the search platform, so let me explain what it does.
I guess, Emmanuel, you've mentioned it several times, yeah. A search platform, just to make it clear to our users who don't necessarily know what that is, what might be alternatives in this space, and how does this compare to those platforms?
Okay, so if you allow me, then I can name them. So I mean, the common software that we use for search, in the Lucene world, we have a few of them. The main one today is Elasticsearch, of course, which is this distributed platform built on top of Lucene. But also Apache Solr. I could name. There is other platform. You can even find search features right in typical database, I suppose SQL, MySQL, and in cloud platform you can find MongoDB with Atlas. You can find Algolia as an example. So usually find the same kind of logic on those software.
Brilliant.
So yeah, tokenizer. What do we do with tokenizer? The goal is, so remember we were talking about this unstructured sequence of characters. So we have to tell SerialDB always going to recognize words. And again, it's for human, it's easy, right? For software, we can give him some information there. So what we say here, we ask him we'll talk about camel after. I know that some of you already understood what we mean by camel, but let's go talk about class. So the idea with class is to say that each time the class of the Unicode character is changing, then it's a new term. Pretty easy, right? Rather than just talking about white space, but it's often easy and more straightforward to say if the class of the character change, then it's a new keyword. It works pretty well there, right? As you can see, we have letters, and we have a space, another class, it's a token, and so on. This is the same use case. Here we have a punctuation, another class, boom, it's a token, and so on and so on. And with this tokenization now, we have a collection of terms, which is exactly what we wanted to have. A difference with many platforms, other search platforms, is that we keep the punctuations. Most of the platform just keep the letter, the digit. So we decide to not remove this information because you may want to know about it, especially if you are looking for source code. Sometimes you want to also be able to say, hey, the thing that I'm looking for is surrounded by parentheses, right? So this is typically the reason why we don't remove them. Tokenizer, Camel. If you want to use SerilDB to index your GitHub workspace with source code, you can do it. So Camel is a specialized tokenizer that, of course, recognize camel cases. And here we have an example in REST where my rectangle is then split in two words, my and rectangle, just because we went from a lowercase to uppercase. Snake case are already handled because it's typically handled by class, because the class of the Unicode character changed. So we have the terms tokenized. Okay, Camel. Next thing on analyzer, the filters. So once we have the terms, what we want is maybe to add some tolerance in the way we find the terms. So we have several filters. A typical one is Snowball. Snowball is a library that exists for ages and used by all the platforms we were talking about before. That try to just keep the root of the terms. So in this case, and we give also the language, right? Because depending on the language, we don't have the same termination, and so it's optimized for each language. So it's a pretty well-known and well accepted by the community on search platform, right? So accepting in this example, we are removing the eng at the end. Accept, if we would have acceptance, we will remove the ince, accepted, and so on. So at the end, what we keep is just the root of the words. If you put this filter, it's also going in a lowercase. This is what Snowball made by default. So yeah, at the end we have these terms, which means that if you look for acceptance athlete, you will find accepting athletic. This is what it means, right? It gives a level of tolerance in the ability to find the terms. Okay, filters. So
before you carry on, Emmanuel, just shout out to the community, anyone who's watching. If you've got any questions, maybe on a particular part of what Emmanuel is talking about or showing, or if you've got any other questions or anything else, full text search, indexing, embeddings, indexing with vector embeddings, then write them into YouTube comments or LinkedIn comments or Twitter comments, and we'll answer them as we go through this stream. Sorry, Emmanuel, carry on.
Great, thank you. And perfect. Okay, this is so we wanted this slide just to show the list of tokenizer that we ship in beta 10 and in the nightly already. So we have 4 tokenizer, blank, because sometimes you just want to make something simple. Blank is in space, they have new line, Camel, we talk about it. Class, which is probably the most useful one, we talk about it. And punctuation, sometimes you just want to split on punctuation. So, and you can mix them together, right? You can, in a tokenizer, put all of them, and then each time one of them detect the change, a new token is created. So yeah. Tokenizer filters, we have ASCII, removing the diacritic character. It's typically, if you want to have a search like a like search, equivalent, the SQL equivalent of a like, you would move to ASCII, removing the diacritic character accent. You can tell I'm French, we have accent. EdgeNgram is the filter you use to keep only the prefix. So if you want to do an autocompletion where someone is typing the first characters and you want to have a fast response with all the terms that are interesting, so EdgeNgram is exactly what you need. Lowercase, I will not tell you what it does, you know. Snowball, we were talking about it. So for Snowball, we are using this Rust library, which is absolutely full of different languages. So we have 17 languages, and of course we are going to add more of them. And the uppercase is the opposite of the lowercase, as you know. This list of tokenizer filters will grow, right? It is just the beginning, and we know that there is all other use cases. So please let us know what is missing. We are going anywhere to add some, but if there is an emergency because the next project you want to create with these features require it, I mean, it's really easy for us to implement and fast to implement. So, and you can also contribute, right? Yeah,
absolutely. So any feature ideas or bug reports or anything else you find to do a full text search, obviously other things in SerilDB as well, then jump onto our GitHub. That's github.com/SerilDB. Then you can find the main SerilDB repo in there and add them to the issues. If you want to code in Rust, if you want to try coding in Rust or just starting out, then by all means have a go at some of the issues as well, and we'll take a look at that code and get it merged if possible. But yeah, any ideas and bug reports, jump onto our GitHub.
Yeah, and it's a beta, right? You may meet bugs. We already removed a few of them. But okay, I would like to go to another concept now, which will matter. So let's go to an example of in SerilDB you create a record. That's pretty handy. It's pretty easy. You use this create statement. You give the key. It's a key value store behind, right? So book column 1. And you give the fields that you want to. So it's one easy way for creating a record in SerilDB. Oh yeah, by the way, I introduced this book that is written by Maxel that joined SerilDB just 2 weeks ago, if I'm not wrong, right, where we at. And yeah, and if you want to start Rust programming, this is one of the books that you may want to have in your library. So what I want to talk about is primary indexing. SerilDB already have indexing. When you create a record with book column 1, then you have a key, and this key is the primary index in SerilDB. And this is the reason why when we do a request, when you use this related, you know, when you, in SerilDB you don't have this difficulty in making join. You can make a field with a link to another record, and you can chain them together and take them together. And this is fast and efficient because we have this logic of primary key or primary indexing. So SerilDB has already this. What we introduce with full text indexing is what we call secondary indexing. So it's not anymore an index on the key, but it's an index on the field, which are inside the value, right, or inside the record. So, so in this case, when we are doing select star from bookware, and we are setting ESBN, we are using the index if available on this field, or title with this. Oh, look, there is a new operator here. I'm going to talk about it just after. So this is secondary indexing. By the way, it's not only full text indexing that is now on the spot. It's also normal indexing. So we have normal indexes and unique indexes. Yeah. Toby, you wanted to say something?
Yeah, I was just going to say that. So that at operator now obviously has some more advanced functionality, which we'll see in the future slides. But is that similar to the like keyword then in a relational database? Is that kind of its closest comparison?
Yeah, we could say that. So like as a semantic that is. So it's supposed to accept, you know, this character ampersand and maybe so there is. So we decide to not use like at this moment because you don't want to confuse users. And if we want to implement like in a way, the SQL word is usually using it, then we may keep the like keyword for the way it is for other platforms. But yeah, it's not
like
far.
is kind of like a regular expression, whereas this actually delves into an index a bit more. Okay.
It's more close to wildcard than regular expression, but yeah, and regular expression will be is part of the roadmap of full text as well. So at some point we will support it fully, by the way. So that will be really interesting.
Awesome.
Okay, so next statement, we now have still defined, right? And we have defined index, where you can create an index. In this case, we are creating a full text index. We give a name on which table or entities we want to create this index, which fields plural, because you can put a sequence of fields. Here I just put one, but you can put a sequence of fields. Search is the type of full text search index. Which analyzer is applied to the text that we are going to index. This is probably the most boring part, which is BM25, which is the algorithm that is used by everybody on the field on search. Now there is also vector search. So the reason why we put BM25 here, because we want to know which algorithm you want to use. BM25 is available now, and vector search is going to be available soon. Those parameters are really specific parameters to BM25. You can remove them. I didn't update the slide, but now you can already just put BM25 and that's fine. And highlights is when you want to specify that you want to do highlighting. Why we put that as an option? Because it's going to store more information on the database. If you don't need it, then it's better to not ask for them, because indexing will go faster. Right? Full text index. Then you have unique index. So if you want to tell that one field contains a value that should be unique, like an email, like everything you want. So yeah, an ISBN, because we are in the book logic. So of course there is only one ISBN per book. So okay, so we create an index with this name, telling that for book, ISBN is supposed to be unique. And if you create a new book with the same ISBN of a book that is already in the database, then you will have a nice error to tell you, no, sorry, it's already booked. Unique. And then you have the simple index or normal index, where you just want to have a query faster. And here we are going to Maxwell made already several books, by the way, so several ESBN. So if you want to find all the book from one author, you are going to use that kind of index to speed up the query. Good. Indexes. So we have three kind of secondary indexes: full text search, unique, and normal. So this is new, and it's not enough, right? Because now we are indexed the data, but it's not enough. There is something that is missing to be able to benefit of the index, and this is now the next concept. Oh yeah, the matches operator. We just talked about the study. This matches operator is the operator that you use to say, hey, I want to make a full text search. So I want to find the two terms Rust Web in title. It's like any other operator. This is something important. The idea there was we didn't want to integrate something like this and say, okay, now you have a field where you can create a Boolean query. We wanted to go further and fully integrated that in the where clause. So it's just an operator like any other, and you can mix it with any other operator, and you can make a really complex statement and just have your full text predicate mixed with others, right? So
before you carry on, Emmanuel, we've got a question for your previous slide, which is Unix indexes are already on beta 9.
Yeah.
So they are, but they aren't. I'll let Emmanuel explain.
Yeah, so the index is there, but it blocked the creation, by the way. So it's already a feature that works. But now we are going to use it to benefit of it in another way. We are going to see that just after.
Perfect. So yeah, undefined. It did prevent you from creating the record of a unique value.
Yeah.
But we didn't ever use indexes when you selected from. So this is where Emmanuel's next slides will tell you exactly how, what you can do with the full text search and other traditional indexes going forward.
Exactly. Okay, so this is an example of query that use there's a reference here. We are going to talk about it just after. There is two forms, so with or without this reference. And it returns a record the same way it returns a record when you just do a normal where request. Yeah, thanks for Yusuke. Yusuke is the guy of the team that helps me in defining the specification of what you see today. And it was his contribution of saying, hey, we need this reference, and you are going to understand why we need this reference. Okay, new thing, highlighting. So now we have a new set of functions, search functions that you can use anywhere in SerialDB. So you have a search column highlight, which lets you highlight the result of the field that contains the result of your search. So here we were looking for title, and now you understand the reference. In this reference, we say that we were looking for title for Rust Web in title reference one, and we can just use this reference in search highlight. And search highlight knows that you want to highlight title, and it's a SQL statement, right? We can just give him a name. It could be something like anything you want, right? So here we say title again, but it could be title highlight if you want. And what happened is that we are taking those two tags, but it can be anything else, right? It does not require to be HTML or whatever. It is just a sequence of characters. You could use dollar or whatever, or an opening parentheses, closing parentheses. You decide. And what we do is that we're just making the highlighting for you, and we provide this title with the highlighting surrounding the two terms that we're looking at. Easy, search highlight. But maybe you want to make the highlight yourself. You don't want us to do the highlight. There is many reasons for that. You maybe want to have a different way of putting emphasis in some content. That's perfectly fine. So we introduced the function search column offset. Same thing, simpler. You give the reference, so we understand that you want to have the offset for title, for Rust Web looked up in title, and rather than giving you the content of title, we give you this structure, which looks a little bit weird, but it's pretty easy. We say that the first item in title, because title can be an array as well. I don't show that as an example, but you can index one field, but also an array of strings. And in this case, you will understand that it is the first index of this array of string that contains highlight. And you have start offset and the end of the offset. So from character 0 to character 4, this is the term you want to highlight. For character 5 to character 8, this is the second word you want to highlight. E is between S, because we present that in an alphabetical order, right? So it's just a convention that is common in SerialDB, to be, if I'm not wrong, right?
Yeah, exactly. Every object is stored alphabetically.
Yeah.
So all the keys are ordered. Exactly.
So this is the reason. Search offset. Thanks, Misha. Misha was the guy that was saying that it would be useful to have the search offset, and he was the first one using it in the search on the documentation that you will probably see really soon on the website. Then, okay, search function in the package of search functions, search score, because of course here I show example with just one result, but you may find few items over 1,000 or million of items, and you want probably the one that match better first, the more relevant one. So this is where the scoring function is ended. So the nice thing is that you will see in the second slide the nice thing. The first thing there, it's simple. You put again the reference. You see how useful this reference is, because we have one score for each predicate. So if you may have several predicates that will provide different score. And but in this case, we have only one, and we have the score related to this one. And it's a SQL statement, right? So you can order by score descending. The higher the score is, more relevant it's supposed to be.
So this enables people to search different fields and have different scores or different weights for each of those fields. So some fields might have more importance than other fields.
Absolutely. absolutely. And this is what happened there. We call that advanced scoring, but it's now that we go inside, we understand it's much simpler as it looks like. So typically here we are looking again for those two terms, but in the title, reference 1, and content, reference 2. And of course, if I look for a book and I put terms that appear in the title, it's more relevant than if it is on the content, right? So the way to tell that in your SQL statement is that we have search score 1, which is the score of this one, and here we just give a factor of 2. It has a weight of factor 2 compared to the search on the content. And of course, the scoring is absolutely up to you. And you define the scoring that you want. You could even order by first the score on the title and as a second key for the ordering the score on the content. And this will be exactly the way Algolia is usually doing the scoring on multi-field. But here you have all the options. You can make this way or the other way. Make something very complex, you decide. And you can, of course, mix together all the functions that are available in SerialDB, right? Because again, it's not plugged inside a function or whatever. It is really part of the core of the SQL system in Serial. They are just functions like any other, so you can put them together.
We've got a question here, Emmanuel, from Andre Tudor, and he says, can we use wildcards in the search terms at the moment?
Not yet, but it's on the roadmap. It's partially there. I mean, the way we build the index let us already do it, but it's not yet on the workload. So yeah, it may be already there by the release in September, but it's definitely in the roadmap. Wildcard and regular expression, which are a little bit different and both interesting.
Awesome.
Advanced scoring. Okay, so when we have indexes, we have an opportunity, which is making the query faster. Today in SerialDB, when you make a search, when you add filters, we add clause in the where, we still iterate over all the key and the value in the table. So now that we have those indexes, we have the opportunity to say, hey, if you are using searching in a field that is covered by index, then I can use the index to get the list. And then we don't have any more to iterate over all the record. We can just iterate over the records that match the query. And in some case, it can be really, really faster. So this is a new concept that appear now in SerialDB, the query planner. That works for full text search, but also for every other kind of indexes, including the non-unique and the unique. So, and of course, there is two things that come there. The way you see that there is a query planner is that now you have an explain parameter. So you can see here that there is a new parameter that you can add in any select statement, and that will let you know if so it's something that you know, of course, from other SQL database, right? So it lets you know what is the execution plan and what is used to execute the query. So you can know if you are triggering or not the index, and if you are facing some performance issue, you may understand what is going on. The query planner is pretty primitive now. It does not handle very complex query yet, but in the beginning, and we are going to make it covering more and more use cases. Query planner, thank you. You were the one that say, hey, look, we need an explain, because you cannot just put a query plan like this. We need to give the user the ability to understand what is going on. And so thank you. Quickly, what we do here, we are making a search, this is the same search you showed before. We are looking on title with the match predicate operator, and we are looking in author. So in fact, here we could have two indexes. We could have one index, a normal index on author, or we can have the full text index on there. So in this case,
Emmanuel, we've got a question from Undefined on that very point. Undefined, don't worry about your English; it's great. So he says, so if I understand, index must be used every time we use a field on the where part. So you were just talking about that. So yeah.
So you don't need, you need an index if you want to use the match operator. That was the question?
So yeah, so in this select statement here, obviously the match operator, the double at symbol, needs the full text search.
Yeah,
but
it
would we need to
require-
define an index on the author field as well if we didn't want to?
No, you don't. No. So the match operator require an index. It's the only operator that has this requirement now. Any other operator function continue to function the way it was functioning before. So no, you don't need an index on all of them. But the match operator required. Yeah, absolutely.
Okay, perfect.
And by the way, we may not require it. We did it this way today because usually you want things to be fast there, but we can be wrong. So this is where you guys need to get feedback. If you think we can easily make it work the way on the table iterator, the way it works today. So that can be an option. So let us know if something useful or not. But at this moment in the Nike and the beta 10, it's a requirement for the match operator. Everything else, no.
We've got another question here on. So if we do select all from accounts where name equals test, should I set an index? So this is a traditional index, undefined, and I'll let Emmanuel answer. But ultimately, it depends on your data. But Emmanuel, what's your take on that?
So I'm not sure I get the question, but yeah, if you want to.
So effectively, the way I see it is if you've got lots of records where you're searching through the name field, then you're obviously better to set an index on that field. Obviously, if you've only got 10 or so records, then there's no benefit to setting it, creating an index for that field. But absolutely, I think it's important to talk about the cost of indexing as well, because every single full text search index or traditional index or unique index, they all have different costs, but they do cost something, don't they? And therefore, as a developer, it's important to know whichever database platform you use, that when you have indexes and when you have views and when you have all these other things that make building apps really easy, you've also got to think about the cost of what it requires every single time you write to a database. If you're writing to the accounts table, and then you've also got to write to the name index at the same time, that's no longer just one write. You're now talking about two writes. So definitely, probably in that scenario, you want to have an index on the name column, but the answer is it always depends on your data.
Yeah, it's a trade-off, right? And everything depends on the use case and your application. So we're happy to listen about your use case and what you face. But yeah, I mean, as soon as you have an index, as Toby just said, I mean, the ingesting data inside the SerialDB goes slower because you have to update the index as well. This is the reason why then the query may be faster, because we have prepared some data structure that make the query faster. But we have to update this data structure each time you put a record that belongs to that need an update. So this index to be updated, right? So, okay.
Yeah. Pythias asked, is that explain statement going to be available in other contexts other than just with the matches operator?
What would be available? Sorry.
Is the explain statement, the explain clause at the end of the select statement, is it going to be available on all queries?
It's always available, and so at this moment you will have three different. In the way the query planner is working today, you have either an iterate index, where we are telling which index is used, right, and on each predicate. So you can see that there. We see that's table block, that is FT title, and the predicate an operator match. And if no index is used, then you have operation iterate table, which is the way it works today with SerialDB without index. I mean, yesterday. So now it's working with. So in this case, where we are doing an OR between two fields, then we go for iterate table. This query planner is going to evolve quickly. I mean, it has its own roadmap, right? So we want to be able to use it for more and more complex queries. So as an example, on beta 10, if you put an OR here, we go to iterate table. But in a few weeks already, if you have an OR between two fields that have an index. So if we have an index on author, an index on title, then we can decide to take one or the other. So yeah, it's going to cover more and more complex queries.
I think that's important to note. Again, this is our first iteration of indexes and search. This is just the beginning. So it's only going to be improving from this point onwards with more functionality, more features, more performance, and everything like that. And we'll come at to the end about kind of what the differences in this implementation are compared to other database platforms and why that's really interesting. So we'll talk more towards the end of this this stream about what's different and why.
Yeah. We provide another statement, which is analyze index, which provides low-level, if I can say that, information about the cost of the index. So as you can see here, you can see the meta structure that are created by the index. Here it's a full text index, and you can see the count of keys that has been because behind the scene we have a key value store, and so you have a sense of the number of keys that has been created to handle the indexing part. You have number of keys, max of depth, because at some point we have a tree of nodes. Okay, so we give information for people that want to have in-depth information about that, and we will be happy to give some information. And you have the total size. Of course, here in this example it was really small, right? But the size of the index in bytes. So this is probably going to evolve, but we start by already providing some information that you can use to understand what is the impact of having the index in the key value store. Index statistic. I would mention this project that we have created, which is so if you go in GitHub, SerialDB, of course, web indexer, you will see this little project, which is a script with Node.js that you can use to index a website. So it's really easy to use, and you can index a website. You need a SerialDB instance, of course, locally running, and it will create the index. It will index the pages. You can make some search. So you can everything that we saw today. You can use it. You can play with it, and it's really it's a 5-minute story. You check out the repository if you have npm run, and it's going. So it's pretty simple.
It's awesome. Just a note, open source, and we're if you've got any suggestions or improvements or feature requests for that as well, then jump onto that URL and hack away or comment away. We're interested in any comments anyone's got.
Yeah, there's a nice README, so you have an option to make it automatically. But in the README we explain also all step by step what is happening, and so it's pretty easy. The documentation that we are going to publish on the website will be powered by this implementation, by SerialDB, of course. So we are soon going to have a search. No pressure to be going to have a search on the website.
That's it, right? Build everything on top of SerialDB. We want to power SerialDB by SerialDB. That's our aim.
Absolutely. And okay, so today on beta 10 and nightly. So that's a little summary of what you get. So define analyzer with tokenizer and filters. Define index, the full text search index. Define index, you already have it before unique, but it's to remember you. The define index, normal index. You have the select statement with the match operator. You have this new function search highlight with the reference on the operator. You have search offset. You have search score. You have explain after a select statement to know if the index are used or not used, and you have analyze index to have an overview of the consumption of the index. And I think we are quite done. Yeah, what is happening next? It's beta 10. We already take time, be sure that it was stable, not yet production ready, but really soon. You may still meet bugs. So we are going to fix them quickly, of course, priority. And so don't hesitate to use it and report these bugs on GitHub, to be already explained. We are going to have quickly more tokenizers, more filters. You have an impact on this. So if you have some requests there, we can just prioritize differently. So we're happy to do that. Query Planner supporting more complex query. So all those things are now about improving this first version of full text. And we are actually actively working on, so we talk about BM25. For vector search, so vector search is this new field that was really revolutionary in search recently and since 1-2 years. And of course, we're going to have our own implementation. The good thing is that what we made already, we already have the vectors from the text that are indexed. But of course, SerialDB is going to support also storing vectors. It's already the case, if I'm not wrong. But and we are going to create a new kind of index, vector search. There will be 2 of them, and they will be available really soon, in the next quarter or quarter after maybe. But it's a matter of before the end of the year, you have vector search as an additional index. I mean, the same way you saw the index full text, non-unique, unique, you will have the vector search index. Two of the kind. One more brute force that lets you check that the things is for the correctness, right? To be sure that you have a result that is the result you expect. And another one that will be more optimized for performances. Okay, so we will talk about these things later, but it's something that we are actively working on now. And I think that's it. Yeah. Thanks Douglas Johnson. Thank Camel Case.
Awesome. Yeah. So we've got a few questions from the community. So Undefined has asked, I'm not sure whether this is possible or not, but is the in the future, is the analyze statement, can it be used to understand the cost of an entire query like you can in Postgres? I'm not sure if that's the analyze statement or the explain statement, but yeah, what's the potential for that now, and what's the potential in the future?
Exactly. In fact, ideally, the query planner should take the information about the index in consideration to decide if it's going to use one index or the other when there is different options. In typical database like PostgreSQL or MySQL, you may manually create those statistics, and then out of the sudden you have better performances because the query planner starts using them because they are available. The funny thing with those information, and this is the reason why in database usually we put them as an optional, or is that it's cost. I mean, these analyze require to go through the whole data structure to collect the information. So it's not something we can do each time we put a new record. So this is the reason why usually on PostgreSQL they tell in the doc that you should do that from time to time, just to update the information so the query planner can do a better job. So yeah, that's exactly what it is for. So it gives you information, but for now we don't do it. But we are thinking how we are going to use the information from this analyzing and have the query planner be more clever by using this information. It's part of the typical process. Yeah.
Awesome. We've got a question from Tan. I'll answer in just 1 minute. I just had a question for you, Emmanuel, which is one of the exciting things you mentioned at the very beginning of this indexing project was around indexing and full text search was the fact that the indexes themselves will work within the ACID transactions in SerialDB. So why, for the community, for the developers who are interested in using SerialDB or already using SerialDB, can you explain why that is different in compared to other databases or platforms and what the benefits are?
So in the search world, which is mostly powered by Lucene in Java, right? Which so Solr, Apache Solr, Elasticsearch, MongoDB Atlas, the cloud version is based on Lucene as well. And then there is other platform that has been inspired by Lucene, and so what happens for those is that they are not really part of the core of the database, and they don't embrace the acidity of the transaction. So what does it mean is that people are using Elasticsearch know that when you are ingesting document, putting a document in Elasticsearch, there is this logic of having all the record being indexed every second, or as soon as you reach 1,000 documents, then they are pushed in the index. What does it mean? It means that when you are pushing a document in the index, if you do immediately after a request, you may not see the document is just ingested, right? And so this is what Acidity is about. So we have incorporated this in the main transaction of SerialDB. It means that when you are ingesting a document, when the Statman return, then you can immediately make a select, and you will see your document. So I think there is not a lot of platforms that provide that today. If you may find that with PostgreSQL, but you will not find that in any typical search platform that we've talked about at this moment. So yeah, I think this is really a game changer, because the search experience is really part of the SQL database on the core, right? So you have not any more concern about synchronizing data between an external tool, or in Mongo this is really weird, because you have a latency between. So you put a JSON document that will be indexed by the full text search capabilities. So the JSON document, you can get it immediately, but you may not find it yet by the content, which is really weird. So that will never happen with Serial.
Yeah, awesome. Absolutely awesome. If you've got any other questions, I'm going to leave you with just 2 comments if there are no more questions coming up. The first one is Miguel says, hello. So hello back to you, Miguel. Great to have you here. Thank you for listening. And then one last question from Tan here about, will live queries come this month? So a lot of you have been waiting for live queries and indexing and full text search. The good news, both of those are coming in the next beta. So that next beta is happening very, very soon. We're just finishing off a few performance improvements and tidying a few things up, but those are coming really soon. So yes, live queries, yes, full text search, and a whole load of other improvements and functionality, which will be going up on the documentation site as soon as that beta gets released. So really exciting release, this one coming, improved performance, improved serialization and data storage size, full text search, indexing, live queries, a lot in this release, and really a release that makes it much more stable going towards our version 1. So Emmanuel, that was incredible. Again, really exciting with what is being built into Surreal and what's there already now, and also looking forward to the future, what's coming. I guess this was just a little glimpse into your world of search and what the possibilities are and what the future holds. And
it's definitely the beginning of the story. Yeah.
Beginning of the story there. Absolutely. So again, anybody, if you've got any, if you want to test it out on our nightly, and also when we release our beta 10, if you've got feature requests, bug reports, or suggestions about how you use full text search, or how you use queries or SQL or anything like that, then we're always welcome to receiving those. Just going to leave you with this. We've got SerialDB World Conference on September the 13th this year. This is going to be in London. If you can join us in London, then we'd love to have you there. We're going to be announcing some really big things, which we think are going to be defining the database industry going forward. But also, if you can't make it to London, then join us online. It'll be streamed live. Just head to serialdb.world, and you can sign up for in-person or live. The conference itself is free, and it's going to be a whole day where you can meet the team, talk about and learn about concepts in SerialDB itself. So it'd be great to have you there if you can join us in person, if not online. And thank you for joining us today for this stream. Emmanuel, thank you. And see you next week, or see you on Discord.